Hello again. Alright, Mercury by Andreas Adolfsson. Mercury is a functioning programming language. It includes imperative features. It is a declarative language which focuses on results rather than what the program does. It is a very efficient language. Now, it is extremely efficient due to the nature of logical programming languages. And as a declarative language, we know that it focuses more on algorithms and output rather than program states and readability. So a lot of the problems you might run into with Mercury would be, or with logical programming languages in general, would be finding the logic rather than writing the code. Now, for the origins, Mercury was developed in Australia by Fergus Henderson. Thomas Conway and Zoltan Somogy were assistants on and helped on the development. In 1995, April 8th, the first edition was released. Within the first 6 months, it was debugged. This is huge, but I will talk more about that in a moment. Sorry about that. Mercury is derived from Prolog and Haskell, which are both infamous languages. Prolog is infamous for its semantics and its logic programming. Haskell is infamous for its compilation and its strong modded languages. Marketed as a functional language with features for imperative languages was huge back at that time. You didn't see a lot of languages that were crossing barriers, and Mercury definitely tried to bridge logical programming and imperative programming. Now, what makes Mercury so special is it supports object-oriented programming in addition to this functional programming it has. It also has an additional compilation layer that most functional or logical languages lack, especially. Prolog does not have any compilation layer at all for especially. It was bug-free within the first 6 months, like I said, which compared to Java, which has taken decades, is a huge deal. It is extremely fast without sacrificing portability at all. So it asymptotically is exactly the same speed as Prolog, actually, which is a big deal for those who don't know. It derives C code instead of native code, which means it can work on any platform, not just the ones designed to specifically implement them. Now, if you don't believe me, here's a quote from Mercury, or from the Linux magazine writer Nils Rudnick. Mercury is an excellent player in the fastest language league. It's suitable for high-speed neuronal networks. It has exemplary compile time, error detection, and profiling. It provides architecture designed for large-scale projects with hundreds of thousands of lines of code. Now, this is not something you see in languages used every day. This is something you'll see in Prolog, but even then, Prolog does not have the compilation stages and error checking that Mercury employs. Now that I have your attention of how fast and efficient Mercury really is, let me explain. It derives its syntax from Prolog, so it's very similar in its appearance. It adds a compilation layer of its own, like I explained aforementioned. This means that before interpretation of the actual program, the debugger can catch most of the errors, which is something Prolog definitely lacks. It supports higher order programming, which I will expand upon in a moment, and it is strongly modded. It has strong types and it supports backtracking. Now, backtracking is something even Prolog researchers give up on implementing, but ever since Prolog and Haskell derived Mercury, we have found a solution to that. Now, as I said, higher order programming it allows for certain functions that we don't usually see otherwise. Closures, currying, and lambda expressions are very specific in how they're implemented. Now, closures are functions or references to, I don't know why that keeps happening, are reference to functions together with its referencing non-local environment. They're usually set up in tables referring to variables that are not in the environment themselves, but would be used or could be used for programming purposes. Now, currying is when we evaluate multiple parameters and turn them into sequences of single argument functions. And in lambda expressions, we have variable binding and substitution in a function. Now, this is one of the biggest deals of the three, at least. Because when we are able to bind and substitute variables is when we're able to really efficiently replace a lot of code. Now, Mercury code looks a lot like Prolog. Like I said, here's an example of the factorial. Now, as you can see, it defines the factorial very, very explicitly. We call it function up front, and we provide an integer, very much like C languages does, and we set it equal to an integer, very much like a C prototype. Instead of writing the integer at the return section in front, we write it at the end. Now, for the actual function body, we have we replace the integer with the actual variable that will be representing the number. And then, very much like C, we implement a regular if-else statement. If n equals 0, then we have our base case, and we return 1. Or actually, we set it equal to 1. In C, we would return 1. Otherwise, we simply return n times the factorial of n minus 1. Very much like C1. It's a recursive function, calculating the factorial. Now, for a slightly more complex code, I'm not going to go through every single line here, but as you can see, here's a code that increments a counter. We initialize a few variables up front, then we initialize a function called app that returns the state of the current state of a value, which starts at 0 and handles a clicker. After that, we define a clicker, which the clicker increments the clicker value by 1. That's all it does. And after that, we have the main function, which we call app.render here. And it takes the state, and it returns the values, and it prints out the button and click me, of course. And the compilation program is simply at the bottom. We have our variable hg application. We have our parenthesis document, which is the requirement of the global document. We have our application and application render, which creates a whole program. Really simple and readable compared to Scheme and other complex languages we've seen. Now, Mercury also compiles to multiple backends. It compiles to high-level C, low-level C, Java, C#, and Erlang. Now, to summarize, Mercury is one of the fastest language available, especially if you're dealing with imperative languages. Then Mercury will usually be able to encompass all the imperative features and perform them in a logical way, providing a much faster execution. Now, it's very readable, as you saw. It's extremely efficient, easy to use, considering most functional languages can be a headache. It can be a mind puzzle to figure out what some functional languages even say, let alone do. It's bug-free, which is a big deal. If you've ever encompassed amazing amounts of bugs as I have throughout the computer science degree, bug-free, I like that. Now, Mercury is going to be my next programming language I learn. I don't know about you. But thank you very much for listening to this. I hope you have a good day.